Good evening, everyone. Welcome to the one problem one day one problem per day series, and this is for the days, that is for tomorrow, which is on 16th. Let me just write it down. This is from 16th to 20th December 2024. Okay, let us start solving the problems. So this week we are going to do problems on gravitation. Anyway, so those who are in need of these problems, that is the online viewers who are looking at these problems, they have only the solutions in YouTube. If you want, you can just put a request to me in my channel itself. You can provide me your email ID so that I can mail you across this particular sheet. Okay, on before itself. Right. Let us start with this. This problem is for 5 marks. Let me start this. The diagram shows a planet nearly 2 stars of equal mass. So these are having equal mass. Okay, each star has a mass of 2 into 10 power 30 kgs. Okay, the centers are separated by a distance of 6.8 into 10 power 11 meters. The planet is at a distance of 6 into 10 power 11 meters from each star. Okay, so this is also given. The planet is at a distance of 6 into, okay, this planet is at a distance of so much. Let me write down. So this distance is seen to be 6 into 10 to the power of 11 meters. This is also given to you. Okay. On the diagram, draw two arrows to show the gravitational field strength of the position of the planet due to each of the stars. What is the gravitational field strength at the planet? Okay. So what will be the gravitational field strength? So this length is also same. So what will be the gravitational field strength? See, star is much larger than the planet and is asking you what is the gravitational field strength at this one. Then only the directions. So you can say the planet gets attracted by the star. So you can write like this. Okay, it is getting attracted along the line joining the planet and the star, and also here also you'll get attracted like this over here. Now while you write it, now what is this for? This is for 2 marks. So see to it that these two arrows of equal length. For example, if some students write something like this is much larger like this and this shorter like this, you will lose a mark. Okay, so see to it that these are of the equal length, which indicates that the gravitational field strength is the same. The reason is because this distance and this distance are same and the mass is also same, and we know that G is given by Gm divided by R square, right? So therefore G is already constant. M here and M here are same, R is also same. So as a result of it, gravitational field strength should be the same. Okay, next. He's not asked you to find out what is the value of it. Okay, next question. Calculate the magnitude and state the direction of the resultant gravitational field. Resultant gravitational field is asking at the position of the planet. Now what can happen? Now what we do is, this is G here, this is G here, and this is G here. G is a vector. If G is a vector, then definitely resultant would be, you need to take the resultant. How do you take the resultant here? What you do is draw a line here, perpendicular here. When I draw this G is like this and this G is like this. Now what is the resultant? Very simple. Resultant should be like this over here. Now how do I find out? So what I need to do is that, let me consider this angle as theta. So this angle will also be theta, right? It appears like an isosceles triangle here. So therefore, if this is G and this is G, the component of G along this direction should be G cos theta due to this field, and due to this one, once again you have one more G cos theta. Since they are all aligned in the same direction, G cos theta plus G cos theta, you can add them up. But at the same time, if you look at this here, the component of G along the horizontal in this direction should be G sin theta here, and due to this one should be G sin theta here. Now these two are equal and opposite, so these two will cancel each other. Thus the net effective gravitational field G effective will just be equal to 2G cos theta. Now what is the value of G? Don't take G equal to 9.8, which will be incorrect. Okay, so you should find out the value of G from here. What is this now? 6.67 into 10 to the power of minus 11. From the data booklet you can get this answer. And then capital M, which is 2 into 10 power 30, 2 into 10 to the power of 30 divided by R square. What is the value of R? R, where is the value of R? R is this one here, right? So R should be 6 into 10 to the power of 11 whole square, because it's R square over here, right? So therefore, now let me solve this, let me simplify this. Let me take my calculator. Okay, so I have 6.67 into 2 is equal to so much divided by The 6 into 10 power 11, what I will do is I'll write it like this over here. I'll write it like this. I'll just write one more line so it becomes clear. 6.67 into 2 divided by 6 square is 36 into 10 to the power of. Here you have minus 11 plus 30 will become 30 minus 11 equal to how much? Plus 19. Plus 19. And here 10 power 11 whole square will be 10 power 22. Okay, so it will become minus 22 over here, right? So therefore, now if I simplify it, so I do get this as, where is my calculator? Okay, so it's here. So I get 6.67 into 2, I have already did, divided by 36, I get this as 0.3705 is equal to 0.37, I'll write, into 10 to the power of, what do we have here? We have 19 minus 22, how much is minus 3? So I will write this as 10 to the power of minus 3 here. Okay, this should now be equal to 3.7 into 10 to the power of minus 4. What is this unit? Unit is Newton per kg. Have you arrived at the final answer? No. Okay, we have just got the value of G here, right? I need to plug in this value. So let me write it down here. I have the value of G is equal to 3.7 into 10 to the power of minus 4 Newton per kg. You can also write meter per second square. Both are same. Okay, now we are already running out of time, but anyway, we'll do this. Then, now we have got this parameter, but I know we need the value of cos theta. How do I get cos theta? See, if this is 6.8, this should be 3.4, right? Because it's isosceles, it should be half of it. The median will bisect it, right? 10 to the power of plus 7. Now, if this angle is theta, that's what I have taken here. Now, I need to find out cos theta. How do I get cos theta? So, I will apply Pythagoras theorem, right? Let me write it down, fresh diagram here. So, this is your 6 into 10 to the power of 11. This is your 3.4 into 10 to the power of 11. And then this is what I need. This is your theta here, right? So, let me name some values here. Let me say this is your label A, B, and let us say this is O. Okay. Cos theta will now be equal to OB divided by AO, right? Now, what is OB? I want OB. Use Pythagoras theorem. We will say OB square plus AB square is equal to AO square, right? So, OB square for OB should be equal to square root of AO square minus AB square. Now, do we know AO square? We already know. What is AO? 6 into 10 power 11. So, I'll take 10 power 11 common. So, otherwise I'll write like this, which will be 36 into 10 to the power of 22 minus AB. What is AB? 3.4 square. I need to use my calculator for this. Into 10 to the power of 22, right? So, when I do this, what do I get? I will get 36. What I will do is 3.4 square, 36 minus 3.4 star 3.4. I get this as 24.4. I get this as 24.4 into 10 to the power of 22 whole square root. When I do this, what do I get? Once again, I need to take a square root. So, when I take the square root for this, I get 4.94. So, I get the answer as 4.94. This 10 power 22 becomes 10 power 11. 10 power 11. What is it I have got? I have got OB. I don't get the final answer. So, I will take this value, substitute it over here, right? I take this value. This is all practiced here. So, 4.94 into 10 to the power of 11 divided by, what is AO? AO is 6 into 10 power 11. 6 into 10 to the power of 11, which should now be equal to 4.94 I already have divided by 6. When I do this, I get 0.824. 8239 I got 0.824 over here. 10 power 11 and 10 power 11 cancels. So, I am just taking the ratio of this. So, I got this value. Now, what do I need here? I need to find out this value, right? So, which should be 2 into 3.7 into 10 to the power of minus 4. Where? From here I have taken, right? I already got the value of G. I just substitute here. Multiplied by, what is the value of cos theta? Let me go down and see, 824, 0.824, 0.824. When I do this, what is the answer that I get? Let me find out. So, I get 2, so just remove this, 2 into 3.7 into 0.824. When I do this, I get 6.09. So, I get the answer 6.09 into 10 to the power of minus 4 unit Newton per kg. And since I have one significant here, what I will do is 6.0, sorry, 2.0, 6.0 I have. So what I will do is I'll just write this as 6.1 into 10 to the power of minus 4 over here. That is 6.1 into 10 power minus 4 Newton per kg. Okay, so this is your final answer. So your marking scheme also gives you the same answer. Okay, so with this we come to an end to this particular problem, and tomorrow we will see the next problem. Thank you.